Imagine a motor running at full speed, but the machine it drives is barely moving. Why? Very often, the problem is not the motor, not the pulley size, but belt tension. Today, we will clearly understand how belt tensions control power transmission, with simple logic, formulas, and real industrial examples. Hello everyone, welcome back to the channel. In this video, we will learn what belt tension really means, tight side and slack side tension, how power depends on belt tension, key formulas explained simply, practical plant-level examples. By the end of this video, belt drive problems will make much more sense. When a belt runs over pulleys, it is stretched. This stretching creates tension in the belt. But important point, backhand index pointing right tension is not the same everywhere in the belt. There are two different belt tensions, tight side tension, T1 slack side tension, T2. These two tensions are the heart of power transmission. This is the side of the belt pulling the load. It carries higher tension. This is the return side of the belt. It carries lower tension. Power is transmitted only because there is a difference between T1 and T2. If both tensions were equal, backhand index pointing right, no power would be transmitted. Now the most important relation. Power transmitted by a belt drive, P equals times V, where P equals power transmitted T1 equals tight side tension, T2 equals slack side tension, V equals belt velocity. Key takeaway, power depends on difference in belt tensions, belt speed increase, either power increases. Let's understand with logic. If T1 equals 1000 newtons, T2 equals 900 newtons, difference equals only 100 newtons, power transmitted equals very low. But if T1 equals 1000 newtons, T2 equals 400 newtons, difference equals 600 newtons, backhand index pointing right, much higher power transmitted. So remember, backhand index pointing right, it is not total tension, but tension difference that matters. The relation between T1 and T2 depends on coefficient of friction, angle of contact on pulley, type of belt for flat belts. T1/T2 equals E caret where mu equals coefficient of friction, theta equals angle of contact in radians. This equation tells us backhand index pointing right, higher friction or more wrap angle allows higher power transmission. Many people think tighten the belt more, transmit more power. This is dangerous thinking. Overtensioning causes bearing overload, shaft bending, reduced belt life, motor overheating. Correct tension is always a balance, not maximum tightness. Low belt tension causes belt slip, heat generation, loss of efficiency, poor power transmission. Slip reduces effective difference between T1 and T2. Result, backhand index pointing right, power loss and belt damage. Consider a conveyor belt drive. Motor power equals 15 kilowatts, belt speed equals 5 meters per second, required tension difference. T1 minus T2 equals P/V equals 15,000 divided by 5 is equal to 3,000 newtons. So if slack side tension is 1,000 newtons, tight side must be around 4,000 newtons. This calculation helps in belt selection, tensioning methods, troubleshooting slip issues. Let's quickly summarize. Belt tension creates power transmission. Tight side tension T1 is always higher. Slack side tension T2 is always lower. Power depends on not total tension. Overtension damages bearings. Undertension causes slip. Understanding this relation helps you design, select, and maintain belt drives properly. If this explanation helped you understand belt drives clearly, backhand index pointing right, like the video backhand index pointing right, subscribe for practical mechanical engineering concepts, backhand index pointing right, comment if you want a video on V-belts versus flat belts power comparison. Thanks for watching, and I'll see you in the next engineering lesson.